In this lecture, we're going to talk about the positive rays. Positive rays was discovered by Goldstein. Goldstein uses the same way, same process, same tube, but the difference between the discovery of cathode rays and positive rays was that he uses the perforated cathode in discharge tube. Perforated means there was a space between the cathode foil. As in the cathode ray tube's discovery, discharge tube, vacuum, glass tube, battery, negative terminal, positive terminal. But the difference is that there is a space in the cathode area. Now, just suppose there is hydrogen gas inside the tube. Now what will happen? When the cathode rays are just strike to the bonding of one hydrogen to the second hydrogen, because we know that there is a valency in the valence orbit of the hydrogen, so they just make the bond. So when the hydrogen makes the bond and cathode rays work on it, it breaks the bond of the two hydrogen and they becomes individual. Now when the cathode rays acts on the individual hydrogen, it breaks out the electron and proton. It separated the electron and proton. Now in this condition, the electron just attracted towards the positive terminal, but the proton was attractive to the negative terminal. Now, as we know that there are perforated cathode tube, so the proton just pass from the holes or from the space in the cathode. That was the discovery. Now, at the discovery of the cathode ray, we just talked that there was a fluorescence in this area, but here the fluorescence is in this area. So that's all about this experiment with respect to hydrogen. As we know, the hydrogen is used, the gas is used, so we can use different types of gases. We can use oxygen, we can use helium, we can use carbon dioxide. It's up to us. So let's talk about the helium one, which is heavier than the electron and heavier than the hydrogen, and it has more protons, neutrons and electrons. Now when the cathode rays strikes to the bond of the two heliums, the bond are break, it becomes individual element. So when these act on the individual element, one electron just being separated from the atom. Again, when the cathode rays are struck or collided to the nucleus, it becomes only the proton and neutron. Now here, this nucleus just got attracted towards the cathode terminal and electron just attracted towards the positive terminal. And that's the change. More protons just get attracted, more fluorescence, the more it becomes more fluorine. Now these rays are called positive rays, or we can say canal rays, because it just passed from the canal. The discovery was become possible because of the canal, so we just call that canals. This was respect to helium. Now what's the difference? We have used the same we have used the same tube, same charges. So what's the difference between the gases and what it affects the protons or positive rays? Now in hydrogen gas, there were less amount of electrons and protons, while in helium there are greater amount of both. As we know, H is equal to 1 proton, 1 proton, 1 electron and no neutron. Its weight is less, it is smaller, while the helium gas has 2 electron, 2 proton and 2 neutrons. That's bigger and that's heavier. That's the difference. Hydrogen has less mass while helium has more. As I taught, more proton, more mass, less neutron, less proton, less mass. Hydrogen has more Em than helium. Now what's the Em? As I taught, Em is the ratio of the charge and the mass. As we know, hydrogen gas has the charge, also the mass. But here the mass is lesser than the helium, and that's the difference. Hydrogen will get more. Like, just suppose one charge is on the electron and 1 is the mass of it. The answer will be 1. While the helium has 4, the answer will be 0.2. So that's a huge difference. 1 and 0.2. 1 is greater. So we just thought that hydrogen has more EM than helium. Heavy gas has less EM and more mass. Now heavy gas is EM, as I taught, hydrogen has less mass but it has greater EM. So it is written in this statement. Let's prove that PR, positive rays, has EM or not. By passing the positive rays from the electric field, it just moves towards the negative one. Now that's a proof that it contains charge. When we passes the PR from the magnetic field, it just moves towards the gravitational force, the North Pole, and that's the proof that it contains a mass. CR and PR, what's the difference between these both? PR depends on gas while CR is independent. As we know, in the PR, gas is required for the EM. But in the CR, it is independent. It is only the charge, or we just thought that ER is the electron. We can just say that EAR is the electron. While PR depends on the mass or on the charge. EM is greater than of PR than CR. As we thought, CR is independent. It got less EM. And PR dependent on the gas, dependent on the mass, so it has greater PR. PR gives more fluorines than CR. It is heavier, that's why it gives more fluorines. Positively charged are heavier, and in an atom there are more positively charged, and we just have to just got the hydrogen, helium, oxygen. That's why it's heavier. Particles are heavier, and I just thought that. Now let's prove that which is heavier. Then now there's a condition. When we passes the CR from the south and north pole from the magnetic force, so it just goes forward and then it just becomes down. In the PR, it just rapidly becomes down because it has less mass, it has more mass. That's the problem, and that's the point. This is all about today's lecture.